Hey everyone, and welcome to Barcode. Today we will discuss strings, one of the most used classes in Java. You will learn how to create string objects, gain some insights on how Java manages them behind the scenes, and finally some useful methods you will most likely use when working with strings. So let's get started. Strings are a convenient way to store text in Java. They are also immutable, which means their values cannot be changed or modified. We're gonna come back to this in a bit, but first let me show you an example. Let's say we are making a game and now we need to store the name of our players. So we type string player1 equals Kate, string player2 equals Joe, string player3 equals Max, and string player4 equals Kate again. Now the thing is, if you keep creating a lot of string objects, they can be using up a lot of memory. To help with this to some degree, Java has a clever solution. Let me swap over to drawing board and I'll show you, but please note I am no artist and I'm gonna draw with my mouse. This circle is what you call the string pool in Java. What actually happens when you create a string, let's say player1 equals Kate, what Java does first checks if Kate is already in the string pool. If not, puts it in there and references player1 to the memory address where the value Kate is. Now you create your second player, whose name was Joe. Java checks again, is Joe in the pool? No. So it gets written in there. Player2 gets the reference. Player3 was Max. Again, is Max in there? No. So Java puts it in there. Then references player3 to Max. Then comes player4, whose name was also Kate. And when Java checks and sees that Kate is here, it doesn't create a second Kate. It just takes the reference of P4 and points it to Kate. But now what happens if you want to change player4's name to Bob, for instance? If you change Kate in the memory to Bob, then player1's name gonna also change to Bob. And you see where the problem is. That's why in this case, when you wanna assign Bob to player4, Java first checks, is there a Bob in the pool? If not, writes it in there, deletes the old reference, does it actually way faster than I do, and then creates a new reference to Bob. And that's what immutable means in Java. There is another way to create a string in Java, and that is by using the new keyword like this. String player5 equals new string, and in parentheses and quotation marks you pass in the value. Let's say Jack this time. But this works a little bit differently in the background. When you create player5 with the new keyword, and you want to assign the value Jack, Java still checks if Jack is in the string pool. If not, puts it in there. But after that, it picks a memory address outside of the string pool, puts Jack in there as well, and player5 gets the reference to this Jack, not the one in the string pool. There are some rare scenarios when you want to use the new keyword, like when you need a standalone object, but these are really rare. In most of the cases, you're better off just using the string literals like we did with the first 4 players. Now, there is another way to create a string in Java. If you have an array of characters like this, you can use the new keyword. Let's call this string myword equals new string. And in parentheses, you can pass in the name of the array, in this case letters. And what this does, it transforms the letters into a string and puts it into myword. So if we print out myword, we should get coding. And this case is also a bit more special because the string literal coding won't end up automatically in the string pool. Before we dive into the method section, it's important to understand the difference between static and non-static methods. First, the static methods. These belong to the string class itself, not to a specific string instance or object. These are usually used to process other types of data and convert the result into a string, which then you can use as needed. And you use them by typing string dot and the name of the method. On the other hand, there are the non-static methods. These are called unspecific string objects, and it allows you to manipulate or retrieve data from that object. And these can be used by typing the name of the string, in this case my word, dot, and the name of the method. Now let's check out some of the most commonly used methods of the string class. I already cleaned up the code a little bit and I created a new string called my sentence, it is sunny outside, because one can dream. First, let's look at two methods at once, the length and the charAt method. What the length method does, it tells you how long your string is. So if you would print out my sentence dot length, you will get how many characters you have in that string, in this case 19. And what the charAt method does, it lets you access a character at a given index in the string. So if you want to print out the first character in the string, you're going to type in the name of the string dot charAt and index number 0. And if you run this, we're going to get capital I. Now these two methods are commonly used together. If you want to iterate through a string and do things with the characters, like either check them or modify them one by one, you can use these two methods together. You can use a for loop, int I equals 0. Here you're gonna need the length of the string, so you know how many iterations you're gonna be having, and I'm gonna go until it's smaller than the length of it. Because if you remember, the indexing starts at 0, but the length gonna give you back the absolute length. So if it has 19 characters, the indexing is between 0 and 18, but the length is gonna be 19. So you have to stop before you reach 19, because otherwise you get an error. And we're gonna increment I by 1. And what we're gonna do, we're gonna count how many times the letter S exists in the string. So we're gonna need an integer, count called count. We're gonna start counting from 0. And now, going through the string, letter by letter, we're gonna check if my sentence dot char at index equals S, then we're gonna increase the count. Otherwise we do nothing, so we can leave the S away. And if we print out now the count, we should get 1, 2, and 3. Let's see if it worked. And it did. Next comes the equals method. What it does, it lets you check the values of a string against each other, whether they are the same or not. I brought back 3 of my players. They are all called Kate. And if I want to check if player 1 is the same as player 2, I could try the double equal sign. So I could type player 1 equals player 2, and let's see what Java says. And it tells me it's true. But if I try to check player 1 against player 3, Java gonna tell me false, although they are both called Kate. But if you remember, when we created a string using a new keyword, it was created outside of the string pool. So player 1 and player 2, they both point towards the same object in the string pool. There is only one Kate. They both pointing towards that one Kate. But when we created player 2 with the new string, that was created outside of it. So this Kate is an other Kate actually. So if you want to check whether the values are the same, then you're going to need the equals method. In this case, you can type p1.equals p3. And now we get this true. Now is a little modified version of the equals called equalsIgnoreCase. And what it does, it ignores capitalization. So if I changed Kate to a small Kate and I check them against each other, it's still going to be true. If I would take out the ignore case part, then it's going to get false again, because small k is not the same as capital K, but the ignore case helps with that. The next two methods we're going to be looking at are the isEmpty and isBlank methods. They both have the same purpose, to check whether a string has a value in it or not, but they work slightly differently. Let's check out the isEmpty method first. As you see, I already deleted the value of the p3 string. So if I call the isEmpty method on it, I should get true because there's nothing in it. But if I call the same method on the P2 or P1 strings, I'm gonna get false because they have a value. P1 has Kate and P2, well, has a bunch of spaces. Now the problem with this, P2 for me has no value. For Java it does, because for Java a white space is a character as any other, but for me there is no real value in it. So if I want to check if there is anything else apart from the space, I can use the isBlank instead of the isEmpty. So if I call the isBlank on the P2, what it's gonna do, it's gonna ignore all the white spaces in it, and it's gonna check if there's anything left. If not, it tells me the string is empty. And now 3 methods at once. The first is going to be the contains method. What it does, it checks whether your string contains a given substring or not. So if I want to check if the my sentence string contains sun, then I can call the contains method on it, pass in sun, and it's gonna tell me yes it does, because that is the sunny. Now if you want to know at what index your substring starts, then you can call the indexOf method on your string, pass in the value you're looking for, and it's gonna tell you it starts at index 6. But what's important to note here, it only checks for the first occurrence. So if you have more than 2 suns in your sentence, you only see the first one. So if I'm looking for the letter S, which I have many of, it's only going to tell me where the first is. In this case, at index 4. And in this method, if I want, I can also add an offset, which means the method should start counting at this index. So if I put in index 4, it's going to start counting at index 4. But this offset is inclusive. So if I start counting at index 4, where the first occurrence of the S was, it's still gonna give me index 4. Because it was inclusive. So if I want to start counting after that, I have to give in a higher value, like index 5. And there is a similar method called the lastIndexOf. It does more or less the same, but it starts counting from the back. So it tells you where the last occurrence is. So in this case, my sentence dot lastIndexOf, I put in S, and it tells me the last S is at index 15. And here you can also use an offset. You can say, please start counting from index 14 backwards, and then it's going to tell you the next one is at index 6. If you want to check whether your string starts or ends with a specific substring, you can use the startsWith or endsWith methods. Here we are back to our little game. We have 4 players. They each play either for the red or for the blue teams, and they either play mage or warrior. So if I want to check whether player 1 belongs to the red team, I can call the startsWith method on it, pass in red, and Java gonna tell me yes. If I pass in blue, Java gonna tell me no, not a blue team member. And if I want to know if, for instance, player 3 plays a warrior, I can call the endsWith method on it, pass in warrior, and Java gonna tell me no, not a warrior. But if I pass in mage, Java gonna tell me yes, that is true. Now for the startsWith method, you can also use an offset. That's gonna tell the method, check whether the string starts with this substring, but don't start checking from index number 0, but from the index of the offset. So if I put 1 and I check for red, it's gonna tell me no, that's not true. But if I put in only ed, that means these 2 characters, and the offset means starts checking from here, then that should be true. For the next 2 methods, we are back to the sunny days. The first method is the replace method. And what that does, it replaces one substring with another. So for instance, if I want to replace sunny to rainy, I can call on the my sentence the replace method, tell it replace sunny with rainy, and if I run it, we're gonna get it is a rainy day, very rainy day. The next method is similar, but it replaces only the first occurrence of your substring, and that is the replaceFirst method. And if we run this, we're gonna get it is a rainy day, very sunny day. It switched only the first sunny to rainy. And two more methods to this beautiful sentence. One is gonna be the toUpperCase and the other one toLowerCase. And they do exactly what they say. The toUpperCase gonna switch all characters to their uppercase counterpart. toUpperCase. And if we print this out, Java gonna yell at us, it is a sunny day. But if you do this to lowercase, then it's gonna be all in lowercase. It's so simple. If you have a string that starts or ends with some white spaces and you want to get rid of them, you can use the trim method on it. So first, let's print out this sentence the way it is. And add this so we see where the end is. Here is the end. There are some big spaces in the front and in the back. But if I apply the trim method on it, and I run this again, the spaces are gone. The substring method will return a portion of your original string. So if I use it on the my sentence, .substring, I can specify only the beginning. So I can say start from index number 2, then it's gonna cut off the index number 0 and 1, the T and H characters, and it's gonna return the rest. Or I can also specify the end, say go only until the 10th index, and it's gonna give me only that portion of the string. The difference is the start is inclusive, the end is exclusive, meaning the character at index number 2 gonna be the first character I see, but the substring gonna end at index number 9. So the 9th character I will see, the 10th won't be included anymore. So the start is inclusive, the end is exclusive. The next two methods we are going to be looking at are the concat and join methods. They both serve the same purpose, adding strings together. So if I create a new string, names equals p1.concat p2, this should give me Kate max. And if I print this out, it is indeed Kate max. But with the concat method, we can only join two strings at once together. So if I want to have all the names in the same string, I can either chain the method like this, p4, and if I print this out, I get all the names. Or instead, I can just keep adding to the names string, names.concat p3, names equals names.concat p4, and we get the same result. But the problem with this, it's a little bit tedious and it's also not so elegant. So instead of the concat method in this case, we can use the join method. So let me just delete this real quick. And we do this by typing string.join. And what the join method also lets us use a delimiter. In this case, I'm going to use a dash, then include my strings I want to join. And if I print this out, it looks much better. In the delimiter, you can put a single character, whatever you like. You can put also more than one character. Or you can also put a string, like string, my delimiter equals, let's say ABC. And if the delimiter is my delimiter, then ABC gonna be inserted between the names. I forgot the semicolon. Sorry. There you go. And the last method I wanted to mention is the valueOf method. What this does, it lets you transform other data types into a string. And if you want to use it, you create your string, in this case my string, you call the method valueOf, and as a parameter, you pass in the data type you want to transform. In this case, I'm going to transform my number. And now the myString string contains the number 12,345, but in the form of a string. What can you pass in here? You can pass in all 8 primitive data types, you can pass in an array of characters, or you can pass in an object. But how this works with object, we're going to cover in a later session, because this is a little bit more complicated. And here you have it, the string class. This video got a little bit longer than I expected, but I hope it wasn't too much. If something wasn't clear, or you think I should have explained it differently, please let me know in the comments. And if you liked the video, please hit like and subscribe, it helps a lot. Thank you and see you next time.